As today topic is semiconductor. So a semiconductor we define using band theory. What is band theory? Everyone know what is the atomic structure. So in atomic structure, inside nucleus, neutron and proton there, and outside nucleus there are so many orbits. So whatever number of orbit nearby this nucleus, that orbit is called valence band. Whatever number of orbit adjacent to nucleus, we say that is valence band, and whatever number of orbit have some distance from the nucleus, we say conduction band. Means in this case we can say this is conduction band CB and this one is what? Valence band VB. Nearby nucleus whatever orbit will be there, valence band, and far away from the nucleus that will be conduction band. So based on this theory, conduction band and valence band, we have a definition of a semiconductor. How you define? First we will define conductor. Conductor means like which conduct electricity. Everyone know conductor means that easily conduct electricity. So this band is valence band, means that band is nearby nucleus. Means whatever number of orbits are there, that is nearby nucleus. Obviously there will be electron in this one. And this band is called conduction band. In case of conductor, there will be electron in conduction band as well. Just if you see this thing, in case of conductor, there will be electron in the nearby orbit and there will be electron in other orbit also. That orbit has some distance. So in this case, there will be electron in valence band and there will be electron in the conduction band. So when you apply electricity, or else you apply heat, or else you apply light on this one, if you strike light on that one, in all three cases, this electron will jump from valence band to conduction band. Easily they can jump, and this gap is called forbidden gap, delta E, or else simply we say energy gap between the band. We also say forbidden gap, and that gap is very small in case of a conductor. It means it's easy to jump from this to this one. It's very easy. So if you apply electric field over here at this point, they simply can jump from this point to this. And already we have electron over here. So when you apply any electric field in this case, in case of conductor I am talking about, when you apply electric field, already they have electron in the conduction band, and some electron they can jump from valence band to conduction band, and they easily can jump easily. Why? Because there is a small gap of energy. This forbidden gap is very small in case of conductor. In fact, in some conductor that gap is overlapping, means this conduction band and valence band they overlap. So basically there is a no gap. So that's the reason when you apply electric field in case of a conductor, so what happens? There will be electricity. Why? Because this gap is very less. Already we have electron in the conduction band that participating in conduction, and this gap is very less. That's why this electron easily jump from this point to this one. It's easy to jump from valence band to conduction band. So this is about conductor. What about insulator? In case of insulator, what happens? This gap is very large. In case of a diamond, if I tell you, that will be 6 electron volt. That is huge gap for electron. Okay. Now, if so many electrons are there in the valence band, this is also called valence band VB, and obviously this is called conduction band. In case of insulator, what happens? There are electrons present in valence band, but there are no electron present in conduction band. So what happens? If you apply electricity over here, in that case, this electron try to jump from valence band to conduction band, but problem is that energy gap is very large. So no matter how much electricity you apply, electron cannot jump from this one to this one. It's just like two islands separated by water. So it's nothing can jump. Two islands means conduction band and valence band. These are two islands separated by water. So if someone want to jump from this to this one, so they have to cross that water. But this gap is very large. So no matter how much electricity will apply, they are not able to cross this gap. So that's why no matter how much voltage you apply in case of insulator, we won't get any electricity. So that is all about conductor and insulator. Now our main part is that basically this chapter is semiconductor, but we need reference of a conductor and insulator to explain semiconductor. That's why I explained conductor and insulator. Now main part is this one. This one is semiconductor. So most easily available semiconductor is 14th group of a periodic table. Basically we use silicon and germanium. Two semiconductor we use silicon and germanium. Other also we can use, but it's easily available silicon and germanium, that's why we use. So if you see atomic structure of silicon and germanium, then their outer shell, in outer orbit there will be 4 electrons. You know electronic configuration 1s2, 2s2. So if you see that outer orbit, there will be 4 electrons. And if I define semiconductor using band theory, so what happens? There will be some electron over here. In this one, some electron over here. This gap is less than insulator. This gap is, this delta E, this is called forbidden gap or else simply energy gap. So this forbidden gap less than insulator, but it's a more than conductor. It's a less than insulator but more than conductor. This delta is less than insulator but more than conductor. So what happens is, when you apply very less amount of electricity, less amount of electric field, like value of electric field, magnitude of electric field is less. In that case, this electron not able to cross this point to this one, means they are not able to cross this valence band and go to conduction band. When you apply less amount of electric field. But when you apply more amount of electric field, if electric field intensity is very high, in that case what happens? These electrons able to jump from this to this one, so they will jump at this point. And when they will jump at this point, so in that case there will be gap created over here. That is called vacancy of electron. This is called vacancy of electron. When electron will jump, obviously electron is reaching in conduction band, so there is vacancy of electron in valence band. That vacancy we say it's a holes. This vacancy called holes, and this one is what? Electron. So basically what is semiconductor? Semiconductor gap, in forbidden gap, less than insulator and more than conductor. So what will happen at less electricity, less amount of electricity? It electron does not jump from valence band to conduction band, but more amount of electricity means at more value of electric field it will jump. So at less value of electric field, nothing will happen. At more value of electric field, it conduct electricity. That's why we say semiconductor. Okay. Now we can also say at less temperature. If you give some temperature to this one, nothing will happen. But more temperature you give, in that case electron will jump from this to this one. So there will be conduction of electricity. So semiconductor means at certain temperature, at certain electric field, it does not conduct electricity, and after certain electric field or certain temperature, it conduct electricity. So this is the difference of conductor, insulator and semiconductor based on this band theory. So this is all about conductor, insulator and semiconductor based on band theory, and thank you.